Good morning, students. Can you see my rating pad?
Yes, sir.
Okay, thank you. We want to continue our discussion. Last week we were talking about the impulse response and the step response of the difference, the filter with the difference equation you see in the red block. Okay. And we found out that y of 0 was 1, and y of 1 was 0.5, and y of 2 is 0.25. This is when the input was an impulse. And so the output is called the impulse response. And if you look carefully, you get an equation for the impulse response. And that's at the very bottom. So this is a new piece of information. H of n is actually 0.5 to the power of n, u of n. So we didn't state that last class, but it should be obvious that it's true. Now, in the future, we will derive these equations for the impulse response without having to do the numerical work first. And we use something called the Z transform. The Z transform. In 320, we use Laplace transform. In this course, we use the Z transform. What's the A vector for this filter? What's the A vector?
That's 1 and 0.5.
No.
One and negative 0.5.
Thank you very much. So this is y of n minus 0.5, y of n minus 1 equals x of n. This is A0. That's A1. And that's B0. So clearly A0 is 1, A1 equals negative 0.5. So the A vector is 1, negative 0.5. And B0, does somebody have their mic on? Ms. Pinto, turn your mic off, please. Ms. Pinto, are you present? I guess Mr. Pinto's device is present, but he's not present. I don't know why students do that. Mr. Pinto, turn your mic off, please. So B0 is 1, and the B vector is 1. The first thing I want to do today is show how we do this in octave. We don't have to do this numerically. We get the output pulse, we get the output, and once we know the A vector and the B vector. All right.
I have a question about the vector.
Yeah, go ahead.
If it had a delay, we'll still write it the same statement if it was -4.
Say again?
The y delay was negative. Say for instance, it was negative 0.5 y and -4. Would we write it the same way as the a vector?
No. This here, this here, this is delayed by 0. This is delayed by 1. The next one will be delayed by 2. You understand what I just said?
Yes, I'll have the right zeros in between.
Exactly.
All right.
Right. All right, who am I missing? I'm still missing Kerr. Okay. All right. All right. It's a program I wrote. It's called ELT 429, but don't worry about that. That's not quite true. The first thing we need to do is define.
I think we can see your screen.
You'll see in my my Office screen.
No, sir.
So now come up.
So you can see my Office screen.
Yes, sir.
Yes, sir.
Okay. So I named this ELET line 26, ELET 460, any filter, example 629, impulse response. Okay. That's why I named it. First of all, I define, I have one, I'm taking -2 to 7, -2 to 7. All right. Then I'm going to create my impulse. How do I do that? What does line 31 and 33 do? What does line 31 to 33 do?
Line 31 be like the range, something like that.
Folks, all of you done 340, yes? ELT for 340? Yes or no? Have you all done 340?
BC++?
Yes.
Yes, sir.
Well, tell me what line 31 to 33 does.
Is it saying that for when k is equal to 3, x is 1, but otherwise it's equal to 0 from values 1 to 10?
Line 31 to 33 says all x values are 0. Is that not obvious?
Yes, sir.
So far, all I've done for line 31 to 33 is I define a vector, an x vector that is 10 long. X of 1 equals 0, x of 2 equals 0, x of 3 equals 0. Why? Because the impulse response is all zeros, except for where? This is where line 34 takes care of it now. Line 34 says, oh, I caught that. Says the first entry is 1. So now line 31 to 34 is declaring an impulse. Any questions about that? Is silence consent or silence confusion?
Could you repeat that again for me, please?
What is line 31 to 33 doing?
Yeah, I understand. You said their reading is 0.
All right. What is line 34 doing?
You said the impulse at 1. At x.
No, I'm setting the first entry of the x vector to 1. And that creates an impulse. The first entry is 1, everything else is 0. Is that not an impulse?
Yeah.
So the x vector is 1, 0, 0, 0, 0, 0, all up to the 10th place. Okay. And then my a vector, I have to redefine my a vector. This is for another question. And that was 0.5. There's my a vector, my b vector. Okay. So my y output is filter. What filter? The filter that's described by the difference equation given in vector b and vector a. And we're going to have the input. We're going to have the input as x. Okay. Don't worry about line 49. I'm not using line 49. Okay. As a matter of fact, let me put comments line on these. And that means it's not part of the program. Okay, that's not part of the program. Okay, now I'm going to do 2 plots. Okay, that's what line 57 is saying. Line 57 is saying subplot 2 means the 2 plots. And not only that, how do I want these plots arranged on the screen? Okay. The first line 2 is saying I want 2 rows. The comma 1 is saying, okay, and 1 column. 2 rows and 1 column. That's what it's saying. And the first plot, that's the last one, that's the last comma 1, is given by what's underneath. What's it saying? It says plot stem n comma x. So what is it saying? That's saying plot the input. How we know an input is impulse. So that's what we expect to see in figure 1, because I'm calling this figure 1. See there in the title? Figure 1. The second plot is, again, I'm reaffirming, I'm plotting 2 graphs with 2 rows, okay, and 1 column. And the second of these graphs, the bottom graph, is going to be a plot of the output y. And I calculate the y up here with a filter. Okay. Any questions about that? So to be clear, I'm not using this line. So I make it a comment. And I'm not using this line. And I save. And then I go up, copy the name of this file. I write so many files, I have to keep track of what I'm doing. So I have to tell myself this is for ELT. Okay. And I go to command window. And there it is. There it is. What happened to my bigger plot? Try that again. Okay. They're expanded. There you see my top plot. See, two rows, one column. The top graph. The top graph is my input. It's impulse. My bottom graph is the output, the impulse response, which is what we calculated. Any questions about this? Okay, I hear no questions. Let me go back. Now, let me just put it in for fun. Let me put in a delayed impulse. A delayed impulse. Delayed by 2. So then all I have to do is make this x of 3. And what's going to happen? What do you think is going to happen? If instead of putting an impulse, we put an impulse that's been delayed by 2, what do you think is going to happen to the output?
It'll shift to the right by 2.
Yeah, it happens. Why can't I find my graph? There it is. Graph. What was that? Did I save that? So 3. That's not right.
Did you save your changes?
I thought I did. All right, let me try something. They're all I may have to reboot. Octave. And we'll do that. Okay. I may have to reboot my computer. That shouldn't be happening. All right. I know what's going on.
Azar viu uma lei beleza, mano.
Excuse me?
Oh no, never mind.
Oh, what's going on? This is a different file. Look at this name. And look at the name we've been posting. See there? This is example 4.2.
You doing 29?
Exactly. All right. So let's. There it is. There it is. There's your impulse. It's been delayed by 2. No, I take it back. That's still.
Look how you do the graph, but you do. You're going down to -2 instead of starting at 0.
All right. Excuse me?
You heard what I said?
I did not. I didn't understand what you said.
Now it's in the graph going down by 2, but not
You have
What do you mean the graph gone down by 2? What's that? What graph are you talking about? There are 2 graphs here. Which graph down by 2? What does that mean?
Man, you know I talk bad, man.
No.
On the
The purpose of education is to teach you how to say what you mean.
on the
It's,
x-axis.
On the x-axis, what's happening on the x-axis?
Instead of you starting the function at 0, you started at negative.
No, the function is starting at 0.
But then you wanted it to start at a delay.
Yes, but the problem is this. The problem is this. Okay. Let's now. So let's do 4 here. Let's do 4 there. See what happens now. Starts at 1. Do you see that this graph here began at -2, n equals -2, n equals -2, -1, 0, and now this is 1, 2, 3, 4. So x of 4 is 1, okay, and x of 4 corresponds. You got to realize something here. Let me go back. Okay. You see there, k is not the same thing as n. You realize that, right?
Yeah, I see that.
All right. So k equals 1 corresponds to n equals -2. K equals 2 corresponds to n equals -1. K equals 3 corresponds to n equals 0. K equals 4 corresponds to n equals 1. Okay. So now we established the impulse response is right. We established that the impulse response is right. It matches your calculated value. Okay. And let's begin. Let's start this at 0. And let's end up at 9. And therefore, if we're going to live 1, this now becomes x of 2. It becomes x of 2 if we want to delay of 1. There you have it. See, it's starting at 0. We're now starting at 0, n equals 0. So when the output does not depend upon the time of the impulse, we call that time invariant. A time invariant filter, which means the output does not depend upon time. Does not depend upon what time you put the impulse in. Now, if I made the input impulse 5 times bigger, what should happen to the output? What should happen to the output?
Should it also get bigger?
By how much?
5 times.
Exactly. We call that a linear system. If the input increases by 5, the output will increase by 5. That's all we've been dealing with since 120. If the input increases by 5, the output will increases by 5. Okay. Let's see that. So we make the input 5. Save it. And the output should increase by 5. And lo and behold, it does. So I just demonstrated to you, we can find the impulse response. We don't need to use the numerical method, although for that assignment, I want you to use the numerical method because I told you I want to make sure you know how to do it. For the impulse response, I've seen the answers from 2 teams, and one team don't know how to do that. Okay. Now let's do the step response. We did the step response. So do the step response. This bottom. And we uncomment that. Okay, so now that's in circuit. What's line 37 to line 39 doing? What's line 37 to 39 doing?
I think that's saying like from 1 to 10 on the x-axis, all of them could be like as high as 1.
It's gonna be what?
The amplitude could be as high as 1.
Yes. Yes, that's what they're saying. They're saying the input is 1 for all k values between 1 and 10. And k values between 1 and 10 correspond to n values between 0 and 9. Okay. So we're putting in a step. Okay. So we're plotting the and the output will be a step response now. So I get rid of that line, the impulse response line, and I get my step response line. Oh, I did that wrong. Yes. And if you remember last class, the output was 1, then 1.5, then 1.75. So there's my input. It's a step. All right. There's my output. 1, 1.5, 1.75. So that's the correct step response. Okay. So we can plot the impulse response. We can plot the step response. What other response we did in 320? The impulse response, the step response. What else?
You did like a sinusoidal.
Yes, the sinusoidal response. Okay. Well, let me just recap this. So I'm going to slide 2. Clearly, to use a filter command, you have to be able to get the A back to the B back to the filter properly. So this is now a summary. This is now a summary. Okay. This is 1. This is 0.5. This is 0.25. This is 1.5. This is 1.75. And this is 1.875. Right. So this is impulse response.
You're lagging a little bit.
What you want me to do about that?
No comment.
Are you okay now?
Yes, sir.
Okay. Do you see a relationship between S of n and H of n?
Look like a crisscross Arden type thing. That's what I see. Like
You see what? Sorry?
they Arden the step response to the input of the input response to get the next step response. If you understand what I mean.
This here, S of n equals H of 0. The second one, the step response is H of 0 plus H of 1. The third one is H of 0 plus H of 1 plus H of 2. And the third one is H of 0 plus H of 1 plus H of 2. All right, plus H of 3. In other words, this here is those two. This one here is, right, those two. This one here is those two added together. Or we could write that succinctly as S of n equals sum H of k equals 0 to n. That's how we write that succinctly. And that should be no surprise because from 320, what is true? What is true from 320? From 320, the step response is the integral of the impulse response. Or another way of saying the same thing is H of n is S of k minus S of k minus 1. Well, rewrite that. S of n minus 1 minus S of n. Example, H of 1 is S of 0. Actually, it's the other way around, isn't it? It's that. H of 1, S of n minus 1. For example, H of 1 is S of 0 minus S of 1, sorry, 1. So H of 1 is 0.5. As you see here. But again, that should be no surprise because H of t is the derivative of S of t. The impulse response is the derivative of the step response. We know both of these equations. No, I take that back. You're supposed to know both these equations from 320. So the derivative becomes the difference equation. Okay. And the integral becomes the summation. Okay. I expect you to be able to write Octave programs. And if you're going to let your teammate do all the work for you, I remind you, I could give you code to write on the midterm exam. You don't have to run that code, but I give you a piece of code and I can say to you, what does this do? Just like I did earlier today in today's class. What does line 31 to 33 say? What is that doing? So my point is, your education is not complete without knowing a little bit about Octave. If you were in the States, you'd be doing MATLAB, but MATLAB is pretty cheap over there for students, but really expensive for everybody else. Whereas Octave is a cheap clone of MATLAB. Okay. Let's revise. What have we done so far? We said that filters are governed by difference equations. Different equations have an A vector and a B vector. We get the impulse response. We get the impulse response, okay, by making the input an impulse, and then finding the output. We get the step response by making the input a step and finding the output. And also, I demonstrated to you the fact that the step response is the sum of the impulse response, or the impulse response is the difference of the step response, difference between the present value and the previous value. Any questions or comments? Okay. For that homework assignment, you have to find the impulse response. I didn't tell you have to do it by octave, but you may want to check your answer by octave for two reasons. I mean, you want to be sure you did it right, and if your octave results agree with your numerical results, then you could have some good confidence that your answer is right. And if you can't get your octave to agree with you, you can't get the octave to agree with your numerical result, either you're doing your octave wrong or you're doing your numerical wrong. In either case, you have to learn both of them. Okay. I want to do another example involving impulse response. Okay. Page 129. Our input is X, that's the one at the top. We're not given the difference equation. We're not given the difference equation. Instead, we're given the impulse response. So what kind of response is this? The bottom graph, what kind of response is that?
And that's what it's saying, impulse response.
It's the impulse response for that filter. We don't know what the filter is. I'm asking you what kind of response, what kind of impulse response is the bottom graph?
Is it a finite?
Yes, it is a finite. Thank you very much. That's a FIR response. Therefore, we're dealing with an FIR filter. Now, I gave you information on how you find the difference equation. How do you find a difference equation? For an FIR filter, how do you find the difference equation? Folks are not studying after every class.
But Dr. Cartwright, can we just write that as call it impulse? So it'll be delta n minus delta n minus 1. Then you just add the next one plus 2 delta n minus 2. Oh, no.
All right. So all you got there, what you just told me, you told me right. So you're saying H of n. You're saying H of n. H of n is delta of n minus delta of n plus 1. Plus 2. Sorry, minus 1. Minus 2. So that's the impulse response. So instead of having the information graphically, you now have it mathematically. How does that help what I just asked you for? I asked you for what? The difference equation. That's what I asked you for. Of the filter. When we first introduced FIR filters, I gave you a property of FIR filters that you are able to write a difference equation just by looking at the impulse response. I told you how to do that, but apparently nobody bothered learning it. I think I had this on a midterm once. The key is to note this is FIR filter. But that was the key. This is true. This is true FIR filter. We simply replace H of n with Y of n, replace impulse by X of n. It's as simple as that. And this goes both ways. If I gave you the difference equation, if I gave you this difference equation, you could easily come up with the impulse response. I hope you let that sink in now. This is not true. Not true. Well, all right. So since you know how the difference equation, find y of 0, y of 1, y of 2. Let's throw y of 3 in there as well. Find those. Work on those for the next few minutes.
Send them in chat.
Excuse me?
I was asking, do you want us to send them in chat?
All right. Okay. So send y of 0 by chat.
Dr. Goddard,
Yes.
are we using a difference equation we solved for earlier?
Excuse me?
You told us to find y of 0. Are we using that same difference equation?
Mr. Johnson, have you not been paying attention? Did we not derive a difference equation?
Yes, but
For this example we're doing now?
I was trying to wonder what figure it was. I couldn't remember which.
Excuse me?
I didn't know if it was the top or bottom graph.
Mr. Johnson, you're mumbling. Please speak up and slowly.
Which graph? Is it the top or bottom?
Mr. Johnson, what's the top graph? It's on the screen now. What's the top graph?
I think that's the impulse.
Excuse me?
That's the impulse.
That's the what?
An impulse.
I still didn't get what you're saying. That's the what?
You hear me?
What is the top graph, Mr. Johnson?
I think something wrong with Mike, Dr. Godred. He say
Excuse me?
impulse. I think something wrong with his mic. He say impulse though.
I see. That's what the answer you give. That's the impulse. So the top graph is the impulse. Does that make sense? Mr. Johnson, does that make sense?
Dr. Godred, I saying something. I think something wrong with his mic. That's me who answered for him because I heard what he said.
All right. So he believes that saying the top graph is the impulse makes sense. Mr. Johnson, how many impulses do you see in the top graph? You see 3. So why do you call that the impulse? Why do you call the top graph the impulse when there are 3 impulses? Anybody, what is the top graph? Anybody, what is the top graph? Nobody can tell me what the top graph is? I am waiting for an answer. What is the top graph? Okay, I'm going to make this a test. In the next minute, send me by email. Send me by email what the top graph is, and I'm going to grade it. Unless I get an answer in the next 10 seconds, I'm going to make this a test.
You mean the top graph? My why? Anyway, what's gonna be?
I've been asking for the past
That's
5 minutes.
I was working the thing about I send you through text, but let me answer it now.
What is the top graph?
You tell you the equation?
I'm not asking for an equation. I'm just asking you to tell me what the top graph is. What is the graph of?
It looks
You're
like
asking in terms of impulse response
That's the graph of
or
impulse.
it looked like there's
Okay, I get a lot of answers now. Mr. Anderson, let me hear what you got to say. What's the top graph,
No,
Mr. Anderson?
I was saying, are you asking in terms of the impulse response? Because I was saying that's the impulse response.
It is not the impulse response. It is not the impulse response. The top graph is not the impulse response.
That's the impulse, right?
What do you mean it's the impulse? I just had a discussion with Mr. Johnson. Listen, when I talk, I expect everybody to listen. I don't expect you to be doing your own thing. Let's try this once more. What is the input graph? Well, I gave it away. The top graph is the input graph. It's the input signal. The top graph is x of n.
So the bottom graph is the impulse response.
Well, how do you know it's the impulse response?
Because that's the output, right?
No, it's not the output.
Oh,
The
okay.
impulse response is when is the impulse response the output? When is that true?
When the input is the impulse.
When input is a single impulse. Our input is not a single impulse. Our input is 3 impulses. 2 of them delayed. But the bottom graph is the impulse response. So the bottom graph does not come from the input. Because the input is not one impulse. We are trying to find y of n. We're trying to find the output. That's what we're trying to find. That's what I asked you to find. That's what I asked you to send me by chat. And only one person has been doing that. Let's try this again. Please send me y of 0. Send me the output when n equals 0. Knowing that the impulse response to this filter is the bottom graph, and the input for this filter is the top graph with y of 0.
Dr. Gaga, you able to see what I sent you?
Yeah, I think your y of 0 is right. Give me a second, please. Yes, Mr. Roll, that's right. right, folks, pay attention, please. Because when I talk, y'all don't pay attention. I don't know what the hell y'all doing, but you're not paying attention. What do we need to find the output? What do we need to find the output? Anybody, what do we need to find the output? All right.
Dr. Cartwright, would we need to find get the input first in order
I'm sorry,
output? You have to
Mr.
make an equation for the input.
Miss Adley, I heard none of what you said. It was all gobbled. Please try again.
So Anderson, I was saying when we need the input first.
I gave you the input. What else do we need? I get the question gives you the input. That's the whole that we just went through that 10 minutes ago. The top graph was the input. Now that we have the input, what else do we need?
Marvin Monero gone sleepy.
Well, we need some specific value of n to find output.
All right. All right. Yes. We need an n value. Yeah, what else we need? We know that we need to know the input. We need to know n value. I gave you the n value. I told you n was 0. What else do we need? Folks, we've been doing this. I don't know who.
Don't we need the values of the impulses?
Yeah.
Mr. Buchamp, the values of what?
The impulses.
Impulse.
What impulses, Mr. Buchamp? What impulses, Mr. Buchamp?
Like, in previous question, it'll be like, this specific value, like it'd be delta of L of n equal to x of n. But for in this
Listen,
case,
folks, listen to me. To learn a subject, you must learn the language of the subject. I have named everything that I've been talking about. You have not bothered to learn the things that I've named. I have named, when it relates to a filter, I have named a number of things. I have named X of n, which is the input. I have named Y of n, which is the output. I have named the impulse response, which is H of n. I've named the step response, which is S of n. I've named the difference equation. Use those names to explain your answer. I want the output. I want the output Y of n. Right now I want Y of 0. What things do I need to know to find Y of 0?
You need to know what type of filter it is.
I don't know what that means. I mean, have we not already established what kind of filter this is? I mean, it's still on the screen, for God's sake.
Yeah, so
What kind of filter is this?
Hertz.
okay, let me put it like this. So we need the specific values of each x of n.
I mean, wouldn't finding n be enough?
Finding and you don't find
just
No, because I know based on the input, I tell you what
the
each one,
n values.
what each n value is.
Yeah, so you could cross them.
Mr. Adley, I told you what n was. What value did I tell you n was?
N of 0.
N
And
was
it's
0.
0. Think about it. Yeah. You just repeat what Mr. Buchamp is saying, Mr. Adley. You've been doing that now for the past three answers.
I remember that.
Yes, but you're repeating what he's saying. I want to hear you now say, how am I going to find Y of 0, Mr. Adley?
Y is 0, just plug it in.
Plug it into
If
what?
0 is n. Plug it into n. See the equation now. You have Y.
Plot.
You,
You do, wait a minute. Let's get this straight. You're going to plot n equals 0 into what?
the equation.
Which equation?
The equation which you have written here.
Mr. Adley, I don't know
That
why.
was the input, right?
You're going to plot n equals 0 into the input. And how is that going to give you Y? The input is X. How is plotting n equals 0 into the input going to give you Y?
Difference equation.
The difference equation. We need the difference equation. We need the difference equation. And Mr. Johnson, did we get the difference equation? Answer by chat, Mr. Johnson. Did we
Yes,
get the
sir.
difference? We
These are the
did.
different, yes, sir.
Where did we get the difference equation from?
The graph,
Which graph?
the input,
At input.
not the That would have been the second graph.
What was the second graph called, Mr. Johnson? Mr.
I'm not 100% sure, but I could tell you what I think it is.
Tell me what you
Isn't
think it
that
is.
impulse response?
Yes, it's called the impulse response. And what do we do with this graph, Mr. Johnson? What do we do with this graph to get the difference equation, Mr. Johnson?
Well, we read the impulses.
All right. Right now, you're bullshitting. I explained all this 15 minutes ago. I don't know what you were doing when I was explaining this. I don't know why y'all think y'all could do what you want to do while I'm explaining things.
Well, Dr. Godred, we listening, man. We trying to follow you, see?
Mr. Adley, that's bullshit.
Dr. Godray,
I can speak for myself. I was trying to follow along.
Ms. Beauchamp, you have a contribution to make?
now I was saying, could we use the first graph to find each of the x of n values?
I don't want to hear any more about the first graph. I want the names of these graphs.
The input signal,
You're going to use the input signal to find what?
the n values.
No. You're going to use the n values to find the input signal. At n equals 0, you're going to find x of 0. At n equals 0, you're going to find x of 0. How are we going to find y of 0?
You find y of 0 by wherever you see n. On the input, you put 0.
No, not on the input.
Difference equation.
The difference equation. Thank you very much. This is the difference equation. And y'all still haven't answered me. How do we get the difference equation? Mr. Adley claims he's paying attention. Mr. Adley, how did I get the difference equation?
Dr. Godred, I can be honest with you. I know.
You don't know because you weren't paying attention.
No, I was following along, but I know how to get that.
Mr. Adley, I explained it. I asked if there were any questions. You had no questions because you were not paying attention.
So far, the only thing I understand is that we trying to find our end result should be to find the impulse response, which is the second graph.
No, we are not trying to find the impulse response.
Oh?
We're trying to find the output signal.
Oh, so we ain't talking about the second graph. We on the first graph. Okay.
We're not on the first graph. The first graph is the input signal.
But the second graph is the impulse response. So we should be trying to find that, eh?
We're not trying to find the impulse response. We're trying to find the output.
Oh.
We're trying to find y of n. And how do we find y of n? How do we find y of n, Mr. Adley?
By using the differential equation, right?
There is no differential equation in this course.
The equation is.
How is it you cannot name that equation? Why is it you don't know the name of that equation?
That's the equation we're trying to find right now. Where you have the y and the 0 set up.
What's the name of that equation?
You just said it, but I trying to remember it. But I know you just said it.
First time, just change it up.
I don't know why you don't know, Mr. Adley. We've only been doing this now for at least three lessons. This is called the difference equation.
Oh, the difference. I thought you said differential. My bad.
Miss Adley, please stop. The only time I mentioned differential was the very first lesson when I was telling you in 320 we were dealing with differential equations. But in this class, we'd be dealing with difference equations.
My bad. I confused the two. That's all.
No, you were ignorant of the two. How did I get this difference equation? How did I get this difference equation?
We extracted from the impulse.
We extracted from the impulse. The impulse. Which impulse?
Impulse response.
Well, impulse and impulse response are two different things. We must learn the language. I don't know why I am still telling you the difference between impulse and impulse response, and it's almost midterm. We extracted from the impulse response. It's right here. It's right here on this page 3. All you gotta do is read the graph, read the handout, read my page.
Question, Dr. Goddard.
Yes.
This is just a question. You think we could take like one of the classes just to go over the last year's midterm or no?
No.
All right.
No. I assume that was Mr. Kerr?
Yes, sir.
Because you don't come to my classes don't mean I have to work harder.
No, I'm what I'm saying, Dr. Goddard.
People who don't do what they're supposed to do always expect the lecturer to work harder. I work hard every class. Some of you are here, most of you are here. Most of you are here, and some of you are not paying attention even though you checked in. The difference equation comes from the impulse response. For what kind of filter? For a FIR filter. All right, now that we have the difference equation, now how are we going to find y of 0? How are we going to find y of 0?
By substituting in the difference equation.
Substitute what in the difference
In
equation?
the difference equation, wherever you see n, you put 0.
Thank you very much. Y of 0 equals x of 0 minus x of -1 plus 2x of -2. What's x of 0?
X of 0 is 1.
How do you know that?
From the delta, from the, where it is, from the impulse.
What impulse? How do you know x of
Delta.
0?
Delta of 0 is 1, right?
From reading the input graph. See there? I don't know why y'all make things difficult. Here's a plot of input versus n. At n equals 0. What is it? It's 3. It is 3. It is not 1. It is 3.
That's what I'm trying to explain to you from a while back.
I don't know what you're talking about.
I was saying we's getting the values from the same input signal.
We're getting the input values
Yeah, the input
from
values.
the inputs from x of n. X of 0 from this graph, x of 0 from this graph is 3.
Then x of 1 will be 2.
So why you sent me 1? Why your answer is 1?
No, I see when I make the mistake. That's why I'm trying to explain to you. It ain't gonna be like how we used to do it before, where it just used to be
This is exactly what we used to do before. It's just that you have different values now.
yeah, that's what I mean. Ended up different values. You ain't just one value for one specific number.
So x of 0 is 3. What's x of negative 1?
I think that was 0.
Why? How do you know?
I'm reading it on the graph.
There's no value on the graph for it, therefore we assume it's 0. What's x of negative 2?
Zero.
0. So y of 0 is 3. Y of 0 is 3. 1, 1, then we'll say goodbye.
Say it again.
What's y of 1? Send me by chat. Y of 1. Excuse me?
Oh, sorry. No more. My bad.
What's y of 1? Send the answer by chat, please.
Hey, Dr. Cartwright, is it possible to see the input signal graph again, please?
I don't know why you didn't take a snip of it.
Thank you.
I got 2 answers, both of them wrong. All right, I'm going to do it. Please pay attention. Mr. Kerr, I don't know why you're sending your wrong answer to everybody.
My bad.
Wait a minute, I'm not sure it's wrong. Give me a second. Let me work it out. Again, what's y equation? X of 1 minus x of 0 plus 2 x of negative 1. Y of 1 is x of 1. X of 1 from the graph is 2.
Oh, that's when I going off.
Okay. X of 0 is 3. I think Mr. Buchamp had this. And then x of negative 1 is 0. So the answer is negative 1. So yes, Mr. Buchamp, you did have it.
John, semi-pressure.
So I just missed out the negative then, Dr. Goddard.
Yo, man, that's like saying your honey just ain't got no nuts.
No, but I saying I was on the right track. I just forget to put the negative. All right.
No, I don't know that you're on the right track. I don't know what you did to get 1. What I do, 1 is not half the answer of negative 1. If you don't believe me, go ask your bank. You think you got $1 left in the bank, but it says negative 1. Bank says you owe them $1. That's what the bank says. Negative 1 is not the same as 1. It's not even half. Negative 1 is twice wrong. Because not only don't you have $1 in the bank, you owe them $1. So you're $2 wrong. All right. Here's what I want you to do. I want you to finish this off. Y of 0, Y of 1, Y of 2, and Y of 3. And then do it. Do it in octave. Do it in octave. Next class, we are going to discover how to do this without doing the difference equation first. That's going to be something new. So you're going to want to pay attention next class.
Question, Dr. I have a question.
Because it's different from anything we've done before. Yes, go ahead. Adley, go ahead.
No, you can answer this question first. Oh,
Mr. Adley, I can't hear anything you said because you're
yeah, what I was
gobbled.
trying to say is for the homework assignment, you saying we could check our answers with octave? Oh,
Yes, I did say that.
all
I
right.
didn't say you have to submit. I didn't say you have to submit octave. I don't want to see any octave in your answers.
All right.
But before you submit your answer, you could check it with octave and make sure it's right.
All right. Just checking one.
But I don't want to see the octave. Not on this assignment.
All right.
Hey, Dr. Godric, question.
Yes. Go ahead.
So after we find all the y of n's, like y of 0, y of 1, y of 2, and 3, and we make an equation out of that, that would be the output signal equation you're speaking of?
I'm not asking you to make an equation of that.
Yeah, I know. I just wanted, would it be the output signal equation?
Yes, it would be. Just like I gave you that to you earlier today. Just like I gave you the equation for the impulse response earlier today. So your input could have an equation, your output could have an equation, your impulse response could have an equation. But we ain't there yet.
Yeah, you see, there's a lot of different names, and yeah, sure.
Yes, and part of learning anything is learning the names. That's the very first thing you do is learn the names.
Dr. God, I got a question after class, please.
Young man, it's now 20 to the hour. I have a class then. You can ask me a question anytime else.
All right.
Right? Just email me.
I get it right now.
All right. All right, folks. I'll see you on Wednesday.
Yeah,
Right,
man.
okay.